I am Reyhaneh Raissi from the Sorbonne University. This paper is co-authored with Evanthia Dimara, Jacquelyn, Reyhaneh, and Gilles. It is entitled Retroactive Transfer Phenomena in Alternating Interfaces. In this video, I want to encourage the designer to pay more attention to the impact of introducing the novel interface on the previously learned skills. It is important because of the ubiquitous nature of interaction across the application. Considering my personal experience can help to clarify this phenomenon. My mother language is Persian, so I communicate with my family using Persian keyboard layout. On the other hand, my laptop's keyboard has an English QWERTY layout, so at work I use the English keyboard layout for programming, writing articles, emailing, and etc. I'm based in France, and in addition to my research activities, I have some teaching courses wherein the keyboards of workstation are in French. So I have to work with the French AZERTY keyboard as well. In a typical day, from the morning to the evening, I use several keyboards with different layouts and multiple times per day. These keyboards share a lot of similarities. They globally have the same geometry and the numbers have the same location. But there are also some key differences. For instance, the letter A and Q are inverted in the QWERTY and AZERTY keyboard. This example now brings up two main research questions. What is the impact of alternations on performance? And in particular, what is the impact of similarity on performance? To answer this question, I'll provide some background about skill acquisition, which is necessary to introduce retroactive transfer. You might want to compare the performance of two interfaces, for example, our two previous keyboard layouts, QWERTY and AZERTY. Here, interface A seems to be faster, but we learn more by considering the learning curve, which is also called intramodal improvement. Interface A is indeed faster than interface B at the beginning, even though now we can see that the interface B is faster with practice. But is it really fair to compare interface A and B? It is likely that users already have some previous experience with one of the two interfaces, maybe with the interface A. It explains the better initial performance with this interface. As a result, in this scenario, it is more relevant to investigate proactive transfer, the influence of a previously learned interface to the performance of a new interface. The transfer is not necessarily positive. It can be also negative. But this is not the end of the story. We can go one step further and consider the situation that users switch back to the interface A after learning the interface B. This is what we call retroactive transfer. The impact of the new interface, here is the interface B, on the performance of the previous interface, which here is the interface A. Now we can ask these questions. Does learning a new interface has an impact on the previous interface that you use frequently? And does the new interface cause retroactive interference? Retroactive transfer is the focus of our work. A key aspect in SIGCHI is that this alternation does not necessarily occur at one time. We can switch back and forth between different interfaces and have several alternations. Retroactive interference still occurs even in the second alternation. In our work, we investigate retroactive transfer from three different perspectives. We start with literature review, then we describe the finding of interview study, and finally the result of the lab experiment. On the whole, there are really less work investigating this phenomena in human-computer interaction. Therefore, we look to the other areas of research, such as psychology, for inspiration in finding the impactful factors on this phenomenon. As we have seen, retroactive transfer is related to the intramodal learning and proactive transfer. The difference between proactive and retroactive transfer is that in proactive transfer, the previous skill interferes with the new skill. And in the retroactive transfer, the new skill interferes with the previously learned skill. Retroactive transfer is also related to task switching. but it refers to a temporary distraction with a low degree of similarity rather than a learned skill. Retroactive transfer has been studied in psychology. Researchers identified key factors such as similarity, practice time, and rest time. The one that is especially important in SCI is similarity as well as practice time, as the designer can decide the maximum of changes of the novel interface in comparison with the previous or standard interface. We also conducted an interview-based study to better understand the retroactive transfer phenomena when using interactive system. We had 2 rounds of interviews. The first round was on broad phenomena of retroactive interference and in different scenarios. The second round focuses explicitly on the keyboard usage decision based on the finding of the first round. Based on the interview findings, the user experienced interference in their daily tasks clearly when they switch between the interfaces. Most of their experience involved using a keyboard, for example, when alternating between QWERTY and OtherT layout, or such as a programmer who has to code for clients who use different systems. Not just one alternation from one to another interface, they are alternating several times between interfaces. As a final result, they argued that the amount of practice and similarity have an important role in the magnitude of interference. Especially the similarity seems to be a subtle factor. It means when two interfaces are too similar, they have the feeling that it favors the transfer, but sometimes they feel similarity makes them confused. These findings motivated us to conduct a controlled lab experiment, investigating if retroactive interference occurs while users alternate between keyboard layouts, and also studying the impact of similarity, which is important in HCI, since the designer can manipulate it. The goal of user experiment was finding and selecting the sequence of targets from the keyboard layout as fast as possible, while alternating between similar layouts. We initially wanted to use a regular keyboard layout to study retroactive transfer, but as learning a new keyboard layout requires a lot of time, we operationalized the fundamental structure of keyboard bottom and the ability of key selecting. We then present an abstract grid layout instead of a real keyboard to control similarity and proximity factors. Here you can see how the sequence of 4 target symbols is displayed at the top of the interface, and users select the corresponding symbols by touching the grid at the bottom. Selecting an element in the grid layout involves visual search, pointing, and motor control. In addition, the 2-sided layouts allows for multi-finger and 2-handed interaction. For controlling the similarity, we have a control layout A as previously learned interface. To study the impact of similarity on retroactive transfer, we designed 2 new layouts that differ from the layout A. The layout B4 is identical to layout A, except 2 pairs of symbols which are swapped. One is far and one is close to control the proximity. The new layout B8 is identical to B4, except 2 more pairs of symbols which are swapped. In overall, we have 3 conditions. The control condition, in which the users learn only the layout A and had the rest time in between. The users of condition B4 learn both layout A and B4, and the users of condition B8 learn both layout A and B8. Here is the performance of the initial phase of learning for all conditions. The result shows that as we use a between subject design, there are similar initial performance for the same layout A. We obtained this result for the control condition. In this condition, user practiced only layout A and have rest time in between. We can see that the rest time improves the performance. When switching back to a previous layout as first alternation, users experience retroactive interference. We observe condition B4 and B8 are affected by a performance drop, and the amount of retroactive interference increases with the similarity between layout A and layout B. Practicing the layout A in the second alternation again leads to retroactive interference. However, we observe higher performance drop during alternation 1 than alternation 2. We also provided the result for the proactive transfer. If you are interested, you can read the paper for more details. Moreover, in our analysis, we found that the spatial proximity between the elements has no impact on retroactive interference. To end, I'd like to highlight that SIGCHI researchers generally focus on skill acquisition, intermodal learning, and transfer of learning. Now, through describing retroactive transfer phenomena in this paper, we aim to encourage designers to pay more attention to the impact of introducing novel interfaces on previously learned skills because of the ubiquitous nature of interaction across applications. In this paper, we investigated the main impactful factor on the amount of performance drop in retroactive transfer, which is similarity. We also observed that the amplitude of this performance drop decreases by the number of alternations. Another interesting finding is that even a small change in the new interface produces a significant performance drop for the entire previous interface. Thank you for your time and your attention.